Welcome back, students, to the fourth unit, Advanced TV System. In the Advanced TV System, we have seen the detailed introduction regarding the Advanced TV System. What are the advanced TV system that we are using nowadays? After that, we have seen the IP audio, what is actually the IP audio, and what are the things that are included in the IP audio. That also we have seen. IP audio is audio signal is converted into the IP packets, that is known as the IP audio. We have seen everything regarding to the IP audio. What are the things they are included in the IP audio, means what is the exactly procedure of IP audio, what is the exactly procedure of converting audio signal into the IP packets, that we have seen. Now let us see the next point regarding the IP audio. The next point is digital audio quality. In this IP audio, the digital audio quality, it is the ability of a speaker or audio player system to recreate the original digital audio signal with all the key characteristics. That is called as digital audio quality. Digital audio and transmission system impairments includes the different things, that is packet loss, packet corruption, and echo. Some measures of audio quality, they are frequency response, fidelity characteristics, THD, total harmonic distortion, noise signal level, and SNR, signal to noise level, and signal to noise ratio, and crosstalk, etc. All these things are considered in audio quality. And packet corruption and packet loss errors, that will result in muting the audio signals and distortions in the audio signals. Okay, due to the loss of different packets, there can be loss of some of the audio signal, and there can the audio signal that can be muted here also. The compression that may produce small amount of bit errors or the packet corruption or the packet loss, it will cause again muting the audio signal and distortions in the audio signal. The audio codes, they are having different compression ratio, are more than sensitive to packet loss and bit errors. Even small amount of bit errors in speech codec that result in different sounds, they are known as variable, or you can call it a warble. Due to use of the code books process in codes, the warbles are also produced because of corrupted packets during the transmission process, muting the audio, that will result in the packet loss that is detected here, and the distortion in the IP audio system that will be called here. Let us see some of the parameters regarding to the key quality indicating parameters. The key quality indicating parameter, basically we can call it as a KQIP. It is the measurement matrix established to help in evaluating the QoS for the desired performance and prioritization of an IP audio system or IP audio services. Here the first thing or first parameter we can call it as BER, that is bit error rate. What is bit error rate? It is calculated by dividing the number of bits received in error by the total number of bits they have been transmitted. By that we can calculate the bit error rate, that is BER. This thing includes that quality of the digital transmission of the channel. Next parameter is PLR. PLR, it is a ratio of number of data packets that is lost in the transmission, that is compared to the total number of packets we have transmitted. PDV is a minimum and maximum possible delay that a packet will experience, that is as it goes out over a communication channel. This thing is used by application to determine the amount of buffer space that is needed here at the receiving side in order to restore the original data, that is audio or video, anything it can be, the transmission pattern in the digital IP audio or digital IP video communication system. Let us see some of the factors of the audio quality. The audio fidelity. What is audio fidelity? It is the degree to which the entire audio system or a portion of an audio system that is accurately reproduces at its output the essential characteristics of the signal that is given at its input. That is audio fidelity. The next factor, that is MOS is full form of MOS is mean opinion score. It is a measurement of a level of a quality it is as it is perceived by a person. The rating level is varying from 1 to 5 means one it is called as for the bad performance and 5 for excellent performance. For example, good quality of telephone service that has a MOS level of 4.0, that is known as the toll quality. Next factor is FR, that is frequency response. Frequency response, it is a measure of a system linearly or performance in reproducing the different signals across the bandwidth specified. Normally FR in digital audio system, it is limited to zero point 0.5 fs, where fs is equal to sampling frequency according to the Nyquist criteria. Next factor is THD, total harmonic distortion. THD is the ratio of combined amplitude of all the signals. They are related harmonically to the amplitude of the fundamental signals. Okay, it is expressed as the percentage of the signal level also. Crosstalk. This factor, it is transferring of audio signal from one communication channel to the other communication channel. It is expressed as a measure of isolation in the decibels between the desired channel and other channels they are present here. Noise level is a measure of combination of total energy of unwanted signal, whatever the distorted signal that is uh, combined into the original particular signal, that is called as a noise level. If it will be expressed in the decibel also. SNR, signal to noise ratio, that is the ratio of signal, that is the information that we are transmitting, the power of that signal to the noise power in the system. It is also expressed in the decibels. Now let us see some of the audio file format. An audio file format, that is a file format for storing the digital audio data on a computer system, that is called as audio file format. This data that can be stored in uncompressed or compressed format also for the purpose of reducing the size of the file. It can be raw bit stream, but it is usually a container format or an audio data format with defined storage layer. Let us see what are the different types of audio file format. It is an important to distinguish between the different file formats and audio codecs. A codec performs the encoding and decoding of the raw audio data, while the data itself is stored in a file with a specific audio file formats. Although most audio file formats support only one type of audio data, that is created with an audio coder. A multimedia container format as a matroska or AVI also, AVI also we can call it as, it may support multiple types of audio and video data also. There are three major groups of audio format. One is uncompressed audio format, which is for example WAV, AIFF, AU, or raw headerless PCM also. The next is format with lossless compression, that is FLAC. Monkey's audio, that is extension with the APE. WAV packs also, file name extension with the WV. TTA, ATRS, ATRAC, advanced lossless, Apple lossless, and number of things. The next is formats with the lossy compression, such as MP3, Wobis, AAC, track or Windows Media or audio lossy, that is with the extension WM. These are the different groups of the audio file format. Now let us see in detail what is uncompressed audio file format. There is one major uncompressed file format, that is PCM. This is usually stored in a WAV file format on the Windows, or we can call it as it is with the extension PCM, or it is with the extension of .aiff file or the MACOS. The next here in the audio file format, that is uncompressed format, here we can say the WAV format, that is based on the resource interchange file format, that is RIFF, which is very much similar to the IFFF format. WAV and AIFF, they are flexible file formats for the purpose of, they are designed here for the purpose of storing more or very less amount of any combination of sampling rates or the bit rates that we can considering here. Here the BWF, that is broadcast wave format, that is a standard audio format that is created by an European Broadcasting Union as a successor to the WAV format. BWF format, that allows the metadata to be stored in the file. It is a primary recording format that is used by many professional audio systems for the purpose of synchronization with the separate picture element. The stand-alone file-based multiple track recorders for the sound devices, here we are considering in the BWF, that is a preferred format we are using for this purpose. The .cda format, that we can call it as a compact disc audio track, it is also very small file that serves as a shortcut to the audio data format for the purpose of tracking on the music CDs. It does not contain any audio data, so that they are not considered to be proper audio file format. They are only very being used in a small constraint. While the second type here we have considered is lossless compressed audio format. The lossless compressed audio format that stores the data in a less space, and it also eliminates the unnecessary data. Uncompressed audio format, they are encoding both sound and silence with the same number of bits per unit per time, so that whatever the data we are having, by removing that unnecessary data, we are getting exactly the less space needed for the data, and whatever the exactly data that is being transferred here by using this lossless compression audio formats. Encoding and uncompressed minutes of absolute silence that produces a file of both the same size as an encoding and uncompressed minutes of music also. In a lossless compression format, however, the music that would occupy a small portions of file and silence, the small portion of silence that would take up the almost no space at all. The lossless compressed format, here they are enabling the original uncompressed data for the purpose of recreating it exactly. It includes the common FLAC, WAV pack, and Monkey's Audio, and ALAC, that is Apple Lossless. These are the different commonly used formats here in the lossless compressed audio formats. It provides a compression ratio of about 2 is to 1. That is, the file that take up a half the space that is requiring for the purpose of original file required, and after the lossless compression, whatever the space required here, that is being reduced to the half space. That's why a development in the lossless compression of the format that aims to reduce the processing time while maintaining a good compression ratio. This is how lossless compression audio format that is being used in a vast use. The next type here, that was lossy compressed audio formats. In the lossy compression of audio format, it enables a greater reduction in file size by removing some of the data. Means whatever the data we are sending originally, some of the data that is being removed from that, and that's why it is called as a lossy, and we are compressing that particular data here. The lossy compression, this typically achieves for the greater compression of somewhat reduced quality than the lossless compression by simplifying the complexity of the data. Here variety of techniques that we are using for the different purpose, mainly the technique we are using for the purpose of removing the data with the minimal reduction in the quality or reproduction. While for the many everyday listening situations where we are getting this IP audio, the loss in the data, that is the quality that is imperceptible also. This is how the popular MP3 format, that is probably the best known example for the purpose of this lossy compressed audio format. But the AAC format that is found on the iTunes Music Store, that is also very much common. Most formats, they offer the range of degrees of compression, generally that is measured in the bitrate. Lower the bitrate, smaller the file size, and more the significant the quality of the particular loss. This is how we are using the lossy compression audio format for the purpose of different IP audio systems. There are a number of audio file formats. Basically, for example, we can call it as 3GP, AIFF, ALSC, MP3, MP4, MMF, MSV, MXP4, OGG, RA, RM, RAM. Number of file formats we are using here for the different purposes. Let us now discuss what is actually the audio media players. Media player, it is a software or a device which converts the media such as image, audio or video into the form that can be experienced by an end user or a person. These audio media players also support for the compression of different codecs and different streaming protocols also. The media players here we can consider as a software that is like client that run on the multiple computers, or hardware that is mp3 player also we can consider, and firmware that is hardware plus software like the mobile phone with an embedded media player, which means we are having hardware also and software also for the purpose of getting that audio media audio system for the purpose of listening that audio. Now let's move towards the next point. That is, let us see what is actually the IP video. Till now we have seen the IP audio. Now let us discuss about the IP video. Let us see what is actually the IP video. The IP video is the video information here that is transferred, or that is communicated in the form of IP packets or data packets. IP video communication that includes digitization of the video, then video coding, then addressing, then transferring, then receiving, decoding, converting the IP video to its original form of video, that is called as a IP video. The IP video transmission system, or transmission and reception, both the system you can see in the diagram. Here in the diagram you can see the digitization and the compression of the IP video system. Then timestamp process also we have seen. IP address allocation is done in the case of while transmitting that particular data. Next, video that is converted into the different packets of the switching packet network packets of the IP video, and IP receiver. In the IP receiver section, whatever the data in the packet form, that is given to the time sequence process section for the purpose of further processing. And next, videos that is video converter section we are using for the purpose of converting that packets into the into the video. It means that whatever the data we have converted into the packets, and we have reconstructed the original data, original video in the video format. That is how we are using here for the purpose of transferring this IP video. Before going into the details of this transmission and reception of the IP video system, let us see some of the terms related to that. First, let us see resolution. As we have seen, all these terms we have discussed in the very first unit of the audio video engineering, this particular subject. But let us revise these terms. So, the resolution, it is a number of images, or the elements, we can call it as a pixel per unit of an area, that is called as the resolution. The image that is displayed with the finer grid that contains more number of pixels, means reproducing more details of an image, it will need the more number of pixels, and therefore it will be said to be higher resolution image, and vice versa. Next thing, or the next concept we can say is a frame rate. Frame rate, it is a number of images or the number of frames that are displayed for the purpose of a movie observer over a period of time. It is given as frame per second, that is fps. Next is aspect ratio. What is aspect ratio? It is the number of pixels on the screen, they are compared to their width and the height. It will decide the frame shape of an image. The letterbox. Letterbox, it is a method of displaying widescreen images on a standard television receiver, where the widescreen aspect ratio that is much more larger than the standard TV or the PC monitor that is having aspect ratio of 4:3. This thing will cause the image display to appear within the border at the top of the image and producing a horizontal box that is known as the letterbox. The next concept, it is analog video interfaces. There are some of the analog video interfaces as coaxial, that is RF video, PAL, NTSC, and SECM, as we have seen in the first chapter. Next is composite video. Next is S video and component video and VGA videos. These were all the terms they are needed for the purpose of getting this IP video system in detail. Now let us discuss this IP video system transmission diagram, or IP video system transmission in detail. The first thing is digitization of an video. In this, it is process of conversion of video component signals or composite signals into the digital form through the use of A to D converters. Here, the output of A to D converter we are using here in series of a digital pulse. This thing will represent the level of optical images. The digital video that may be created from the analog video with the help of different processes, that is video capturing, quantization, and film to video conversion. These three things we are using for the purpose of converting or creating analog video in this digital video format. In that, the first was video capturing. The video capturing, it is a process of receiving and storing the video images in the particular camera. It refers to the capture of and conversion of the video images to the digital form, means whatever the video format that is being converted into the digital format in the digital video, and that will be further passed for the purpose of different processes done for the IP video transmission. The next was quantization. As we have seen, whenever we perform analog to digital conversion, analog to discrete conversion, sorry, after that, for the purpose of converting this discrete format into the digital format, we have to perform the quantization. Here we are performing the quantization process. It is a process of representing the sample signals with the range of defined digital values, means whatever the sample signals that is in the discrete form, we are converting that is into the digital form, that is zeros and one, and the quantization noise or the quantization error that is a present in the process of different quantization. The next process we are following here, that is film to video conversion. For this this particular thing, this in this we are performing the process of scanning up that film, that is movie images, and converting that images into sequence of videos, means whatever the images we are capturing by using that camera, they are passed by that particular frame for the purpose of converting it into the video formats, that is sequence of images in the IP video communication process. Here the frame rate, it is adapted through the use of pull down processes, because whatever the frame rate we are using here for the purpose of this recording, the film is different than the video. That's why typical film to video conversion here, that is pull down process. Once we have performed the digitization of video, means whatever the video capture that we are converting into the discrete then digital format, after that we will perform the compression here for the purpose of storing that video into that camera. Here the video compression we are using, which is the process of reducing the amount of transmission bandwidth, that is the bandwidth we are using for the purpose of transmitting that particular video or the data rate by the analog processing, and for the digital coding techniques also. The compression of the moving picture that can be done by removing the redundancy within each and every image, that is known as spatial redundancy, or by removing the redundancy between the successive images over a period of time, that is known as temporal redundancy. These two types of redundancy are being done here, being removed here, that is spatial redundancy or temporal redundancy. Here data rates of different compressed video signal, that is 45 to 205 times lower than the original uncompressed video, means that much amount of space it is given for that particular system to store the large amount of data, so that whatever the data original video, the 42 times or 42 to 205 times it is being compressed for the purpose of storing them. That is what video compression we are using here. The video compression that consists of time compression, we can call it as a temporal compression, then coding redundancy, that is called as a data compression, or groups of pictures compression, scalability also, layered video coding, and advanced video coding, that is AVC or H.264, that we have seen in the third unit. Let us see what is actually the spatial compression, which will be called as an image compression. It is an analysis and compression of information within the single frame or image or a section of images or the particular information. Okay, one of the common method here that using the spatial compression or image compression, that is JPEG. You might be familiar with this term JPEG. Whenever you upload an image, whenever you save an image, that is being stored in the format of JPEG. This JPEG has been produced the compression which is able to reduce the bit rate or the pixel rate of an particular image. Here whatever the image, 0.25 bits per pixel, or the quality of the image can be reduced here. The next thing is time compression. Just now we have seen the spatial compression where we are compressing an image. Here in the time compression we are using the temporal compression. It is an analysis and compression of the information over the sequence of the different frames, images, or the sections of an image or information. Here one of the common method is MPEG, that also you might have heard. MPEG, it is part of an ISO, that is International Standard of Organization, and it is stored into this MPEG format, that is time compression or the temporal compression also we can call it as. The next type of compression, that is coding redundancy. Here we are compressing simply the data, whatever the data we are storing, that we are compressing here. It means that it is a repetition of information or bits of a data within the sequence of data in the IP video communication. That particular repeated data that is being reduced here or the compressed here, that is called as a coding redundancy. The coding redundancy that can be reduced using the data compression technique. The given amount of data that is representing with the less number of data bits or the information in the data compression process, that the methods here we are using the run length encoding method and VLE, variable length encoding method, for the purpose of compressing the data or coding the redundancy compression method. The next is group of pictures. Here the frames that we are using, we are transferring the different frames per second. Whatever the frames we are having here for that particular video or image, that frames are grouped into a sequence of or the number of sequences, that will be called as a group of pictures. This group of picture that is encoded, this is nothing but the encoding of a sequence of frames that contain all the information that can be completely decoded within the group of pictures. Here B, P and I frames, they are included within the same GOP. Next is compression scalability. What is actually the compression scalability? It is an ability of a media compression system for the purpose of adapting its compression parameters for different conditions. What are the conditions? That is size of display, which is called as spatial scalability. Then combining multiple transmission channels, which will be called as the layered scalability. Frame rate changing, that is temporal scalability. And quality of video signal, that will be called as a signal to noise scalability. While the layered video coding, we can call it as a process that will be converting video into the several component parts. Means that will be dividing the number of components into the number of parts, where each and every layer that can be combined with the other layers also, for the purpose of production of a higher quality of an output. For example, the layered video coding in DVB, that is digital video broadcasting, the signal will be provided low bitrate layer, that is DVB edge scheduled handheld devices, and high bitrate layer, that is for standard television system. The next term here is advanced video coding technique, that is AVC. We can call it as H.264. It is a video codec which can be used for the use in the MPG4 standard format. AVC codec that will provide the bitrate of 2 Mbps for the SD card, that is standard definition quality, and 6 to 8 Mbps for the high definition quality. The real-time encoding, it is a process of converting the media, whatever the media we are converting, that is converting the media from one format of the data structure to the another format of the data structure immediately, as soon as the media that is available for the conversion. Immediate conversion, that is real-time encoding. And non-real-time encoding, that will be the conversion of media that is done where the amount of time that is performs the conversion that can exceed the time that would be perceived as a real time encoding. Here the next process in the transmission, that is internet protocol packet transmission for the video, as we can see in the diagram here. The video that is converted into the packets, and that is that is IP packets, and they are transferred of the IP video data from one point to the another point, that takes place here in the internet protocol packet transmission. Here the data from the source that is getting divided into the number of short increments or the packets, and they are routed separately for their destination. They are After that, they are reassembled in the proper order at the destination. The different protocols we are using here and stacks which we have been studied in the IP audio system, that will be applicable for the IP video system also, that is TCP IP. We have seen in the last lecture in detail about the TCP IP. Then multimedia protocol stack, IP protocol, that is internet protocol for the audio, TCP protocol, that is transmission control protocol for the audio, then UDP, that is user datagram protocol for the audio, and real time transport protocol for the audio. These are the different IP audio and video system we are applying here for the different purposes. Let us see what is actually the IP video communication process. In that, whatever the packets or whatever the video we have converted into the packets here, the communication in between that packet, that is IP video communication process. This IP video transmission, it is the transfer of video IP packets in the form of multiple images. Now, for the from the source to the destination, this IP video that can be downloaded completely before playing, and it can be also known as file downloading, then transferred as the video that is being played, that is also known as streaming, or it can be played as soon as enough of the media that has been transferred, that is also known as progressive downloading here. Thus the processing these things includes the different issues, that is file downloading, video streaming, that is bandwidth awareness, or intelligent streaming, that is bit stream syntax, and multiple bit rates also. The progressive downloading that also be included here. Here in this IP video communication process, we have done all these processes. All these processes, that is downloading the file, video streaming, and all these things, we will see in detail in the next lecture. Thank you.